Chapter 3. What and how they studied at the universities. It is usually the custom for textbooks of education to dismiss the teaching at the universities of the Middle Ages with some such expression as, quote, "The teachers were mainly engaged in metaphysical speculations, and the students were occupied with exercises in logic and in dialectics, learning in long drawn-out disputations how to use the intellectual instruments they possessed, but never actually applying them. All knowledge was supposed to be amenable to increase through dialectical discussion, and all truth was supposed to be obtainable as the conclusion of a regular syllogism." Close quote. Great fun especially is made of the long-winded disputations, the time-taking public exercises in dialectics, the fine hair-drawn distinctions, presumably with but the scantiest basis of truth behind them, and in general the placing of words for realities in the investigation of truth and the conveyance of information. The sublime ignorance of educators who talk thus about the century that saw the rise of the universities in connection with the erection of the great cathedrals is only equaled by their assumption of knowledge. It is very easy to make fun of a past generation, and often rather difficult to enter into and appreciate its spirit. Ridicule comes natural to human nature, alas, but sympathy requires serious mental application for understanding's sake. Fortunately, there has come in recent years a very different feeling in the minds of many mature and faithful students of this period as regards the Middle Ages and its education. Dialectics may seem to be a waste of time to those who consider the training of the human mind as of little value in comparison with the stocking of it with information. Dialectical training will probably not often enable men to earn more money than might have otherwise been the case. This will be eminently true if the dialectician is to devote himself to commercial enterprises in his future life. If he is to take up one of the professions, however, there may be some doubt as to whether even his practical effectiveness will not be increased by a good course of logic. There is, however, another point of view from which this matter of the study of dialectics may be viewed, and which has been taken very well by Professor Saintbury of the University of Edinburgh in a recent volume on the 13th century. He insists in a passage which we quote at length in the chapter on the prose of the century, that if this training in logic had not been obtained at this time in European development, the results might have been serious for our modern languages and modern education. He says, if, at the outset of the career of the modern languages, men had thought with the looseness of modern thought, had indulged in the haphazard slovenliness of modern logic, had popularized theology and vulgarized rhetoric, as we have seen both popularized and vulgarized since, we should indeed have been in evil case. Close quote. He maintains that, quote, the far-reaching educative influence in mere language, in mere system of arrangement and expression, must be considered as one of the great benefits of scholasticism. Close quote. This is, after all, only a similar opinion to that evidently entertained by Mr. John Stuart Mill, who, as Professor Saintbury says, was not often a scholastically minded philosopher, for he quotes in the preface of his Logic two very striking opinions from very different sources: the Scotch philosopher Hamilton and the French philosophical writer Condorcet. Hamilton said, quote, "It is to the schoolmen that the vulgar languages are indebted for what precision and analytical subtlety they possess." Close quote. Condorcet went even further than this, and used expressions that doubtless will be a great source of surprise to those who do not realize how much of admiration is always engendered in those who really study the schoolmen seriously, and do not take opinions of them from the chance reading of a few scattered passages, or depend for the data of their judgment on some second-hand authority who thought it clever to abuse these old-time thinkers. Condorcet thought them far in advance of the old Greek philosophers, for he said, quote, "Logic, ethics, and metaphysics itself owe to scholasticism a precision unknown to the ancients themselves." Close quote. With regard to the methods and contents of the teaching in the undergraduate department of the university, that is, in what we would now call the arts department, there is naturally no little interest at the present time. Besides, the standards set up and the tests required can scarcely fail to attract attention. Professor Turner, in his History of Philosophy, has summed up much of what we know in this matter in a paragraph so full of information that we quote it in order to give our readers the best possible idea in a compendious form of these details of the old-time education. Quote, "By statutes issued at various times during the 13th century, it was provided that the professor should read, that is, expound, the text of certain standard authors in philosophy and theology. In a document published by de Niffel, the distinguished authority on medieval universities, and by him referred to the year 1232, we find the following works among those prescribed for the Faculty of Arts: Logica Vetus, the old Boethian text of a portion of the Organon, probably accompanied by Porphyry's Isagoge; Logica Nova, the new translation of the Organon; Gilbert's Liber Sex Principium, and Donatus's Barbarismus. A few years later, 1255, the following works are prescribed: Aristotle's Physics, Metaphysics, De Anima, De Animabilis, De Cello et Mundo, Meteorica, the minor psychological treatises, and some Arabian or Jewish works, such as the Liber de Causis et de Differentia Spiritus et Animae." Close quote. Quote, "The first degree for which the student of arts presented himself was that of bachelor. The candidate for this degree, after a preliminary test called responsiones, this regulation went into effect not later than 1275, presented himself for the determination which was a public defense of a certain number of theses against opponents chosen from the audience. At the end of the disputation, the defender summed up or determined his conclusions. After determining, the bachelor resumed his studies for the licentiate, assuming also the task of cursorily explaining to junior students some portion of the Organon. The test for the degree of licentiate consisted in a collatio or exposition of several texts after the manner of the masters. The student was now a licensed teacher. He did not, however, become a magister or master of arts until he had delivered what was called the inceptio or inaugural lecture, and was actually installed meditatio. If he continued to teach, he was called magister actu regens. If he departed from the university or took up other work, he was called magister non regens. It may be said that, as a general rule, the course of reading was 1. For the bachelor's degree, grammar, logic, and psychology; 2. For the licentiate, natural philosophy; 3. For the master's degree, ethics, and the completion of the course of natural philosophy." Closed quote. End of quote from Professor Turner. Quite apart from the value of its methods, however, scholasticism, in certain of its features, had a value in the material which it discussed and developed that modern generations only too frequently fail to realize. With regard to this, the same distinguished authority whom we quoted with regards to dialectics, Professor Saintsbury, does not hesitate to use expressions which will seem little short of rankly heretical to those who swear by modern science, and yet may serve to inject some eminently suggestive ideas into a sadly misunderstood subject. Quote, "Yet there has always, in generous souls who have some tincture of philosophy, subsisted a curious kind of sympathy and yearning over the work of these generations of mainly disinterested scholars, who, whatever they were thorough, and whatever they could not do, could think. And there have even in these latter days been some graceless ones who have asked whether the science of the 19th century, after an equal interval, may be of any more positive value, whether it will not have even less comparative interest than that which appertains to the scholasticism of the 13th. Close quote. In the light of this, it has seemed well to try to show in terms of present-day science some of the important reflections with regard to such problems of natural history as magnetism, the composition of matter, and the relation of things physical to one another, which we now include under the name science, some of the thoughts that these scholars of the 13th century were thinking and were developing for the benefit of the enthusiastic students who flocked to the universities. We will find in such a review, though it must necessarily be brief, many more anticipations of modern science than would be thought possible. To take the example for the moment of magnetism, which is usually considered to be a subject entirely of modern attention, a good idea of the intense interest of this century in things scientific can be obtained from the following short paragraph, in which Brother Potamian, in his sketch of Petrus Peregrinus, condenses the references to magnetic phenomena that are found in the literature of the time. Most of the writers he mentions were not scientists in the ordinary sense of the word, but were literary men, and the fact that these references occur shows very clearly that there must have been widespread interest in such scientific phenomena, since they had attracted the attention of literary writers, who would not have spoken of them doubtless, but that they knew that in this they would be satisfying as well as exciting public interest. Quote, Abbot Neckham the Augustinian, 1157 to 1217, distinguished between the properties of the two ends of the lodestone, and gives in his De Utensilibus what is perhaps the earliest reference to the mariner's compass that we have. Albertus Magnus the Dominican, 1193 to 1280, in his treatise De Minerabilis, enumerates different kinds of natural magnets, and states some of the properties commonly attributed to them. The minstrel Guillart de Provins, in a famous satirical poem, written about 1208, refers to the directive quality of the lodestone and its uses in navigation, as do also Cardinal de Vitry in his Historia Orientalis, 1215 to 1220. Brunetto Latini, poet, orator, and philosopher, the teacher of Dante, in his Trésor des Sciences, a veritable library, written in Paris in 1216. Raymond Lully, the enlightened doctor, in his treatise De Contemplatione, begun in 1272, and Guido Guinicelli, the priest-poet of Bologna, who died in 1276. Close quote. The metaphysics of the medieval universities have come in for quite as much animadversion, not to say ridicule, as the dialectics. None of its departments is spared in the condemnation, though most fun is made of the gropings of the medieval mind after truth in the physical sciences. The cosmology, the science of matter as it appealed to the medieval mind, is usually considered to have been so entirely speculative as to deserve no further attention. We have, presumably, learned so much by experimental demonstration and original observation in the physical sciences, that any thinking of the medieval mind along these lines may, in the opinion of those who know nothing of what they speak, be set aside as preposterous, or at best nugatory. It will surely be a source of surprise, then, to find that in the consideration of the composition of matter, and of the problem of the forces connected with it, the minds of the medieval schoolmen were occupied with just the same questions that have been most interesting to the 19th century, and that, curiously enough, the conclusions they reached, though by very different methods of investigation, were almost exactly the same as those to which modern physical scientists have attained by their refined methods of investigation. One or two examples will suffice, I think, to show very clearly that the students of the 13th century had presented to them practically the same problems with regard to matter, its origin and composition, as occupies the students of the present generation. For instance, Thomas Aquinas, usually known as St. Thomas, in a series of lectures given at the University of Paris toward the end of the third quarter of the 13th century, stated as the most important conclusion with regard to matter that nihil omnino in nihilum redigetur. Nothing at all will ever be reduced to nothingness. By this it was very evident from the context that he meant that matter would never be annihilated and could never be destroyed. It might be changed in various ways, but it could never go back into the nothingness from which it had been taken by the creative act. Annihilation was pronounced as not being a part of the scheme of things as far as the human mind could hope to fathom its meaning. In this sentence, then, Thomas of Aquin was proclaiming the doctrine of the indestructibility of matter. It was not until well on in the 19th century that the chemist and physicist of modern times realized the truth of this great principle. The chemists had seen matter change its form in many ways, had seen it disappear apparently in the smoke of fire, or evaporate under the influence of heat. But investigation proved that if care were taken in the collection of the gases that came off under these circumstances, of the ashes of combustion, and of the residue of evaporation, all the original material that had been contained in the supposedly disappearing substance could be recovered, or at least completely accounted for. The physicists, on their part, had realized the same truth, and finally there came the definite enunciation of the absolute indestructibility of matter. St. Thomas's conclusion, nothing at all will ever be reduced to nothingness, had anticipated this doctrine by nearly 7 centuries. What happened in the 19th century was that there came an experimental demonstration of the truth of the principle. The principle itself, however, had been reached long before by the human mind, by speculative processes quite as inerrable in their way as the more modern method of investigation. When St. Thomas used the aphorism, "Nothing at all will ever be reduced to nothingness," there was another signification that he attached to the words quite as clearly as that by which they expressed the indestructibility of matter. For him, nihil, or nothing, meant neither matter nor form, that is, neither the material substance nor the energy which is contained in it. He meant then that no energy would ever be destroyed, as well as no matter could ever be annihilated. He was teaching the conservation of energy as well as the indestructibility of matter. Here, once more, the experimental demonstration of the doctrine was delayed for over 6 centuries and a half. The truth itself, however, had been reached by this medieval mastermind, and was the subject of his teaching to the university students in Paris in the 13th century. These examples should, I think, serve to illustrate that the minds of medieval students were occupied with practically the same questions as those which are now taught to the university students of our day. There are, however, some even more striking anticipations of modern teaching that will serve to demonstrate this community of educational interests in spite of 7 centuries of time separation. In recent years, we have come to realize that matter is not the manifold material we were accustomed to think it when we accepted the hypothesis that there were some 70-odd different kinds of atoms, each one absolutely independent of any other and representing an ultimate term in science. The atomic theory from this standpoint has proved to be only a working hypothesis that was useful for a time, but that our physicists are now agreed must not be considered as something absolute. Radium has been observed changing into helium, and the relations of atoms to one another, as they are now known, make it almost certain that all of them have an underlying substratum the same in all, but differentiated by the dynamic energies with which matter in its different forms is gifted. Sir Oliver Lodge has stated this theory of the constitution of matter very clearly in recent years, and in doing so has only been voicing the practically universal sentiment of those who have been following the latest developments in the physical sciences. Strange as it may appear, this was exactly the teaching of Aquinas and the schoolmen with regard to the constitution of matter. They said that the 2 constituting principles of matter were prime matter and form. By prime matter they meant the material substratum the same in all material things. By form they meant the special dynamic energy which, entering into prime matter, causes it to act differently from other kinds, and gives it all the particular qualities by which we recognize it. This theory was not original with them, having been adopted from Aristotle, but it was very clearly set forth, profoundly discussed, and amply illustrated by the schoolmen. In its development, this theory was made to be of the greatest help in the explanation of many other difficulties with regard to living as well as non-living things in their hands. The theory has its difficulties, but they are less than those of any other theory of the constitution of matter, and it has been accepted by more philosophic thinkers since the 13th century than any other doctrine of similar nature. It may be said that it was reached only by deduction and not by experimental observation. Such an expression, however, instead of being really an objection, is rather a demonstration of the fact that great truths may be reached by deduction, yet only demonstrated by inductive methods many centuries later. Of course, it may well be said, even after all these communities of interest between the medieval and the modern teaching of the general principles of science has been pointed out, that the universities of the Middle Ages did not present the subjects under discussion in a practical way, and their teaching was not likely to lead to directly beneficial results in applied science. It might well be responded to this, that it is not the function of a university to teach applications of science, but only the great principles, the broad generalizations that underlie scientific thinking, leaving details to be filled in whatever form of practical work the man may take up. Very few of those, however, who talk about the purely speculative character of medieval teaching have manifestly ever made it their business to know anything about the actual facts of old-time university teaching by definite knowledge, but have rather allowed themselves to be guided by speculation and by inadequate second-hand authorities, whose dicta they have never taken the trouble to substantiate by a glance at contemporary authorities on medieval matters. It will be interesting to quote, for the information of such men, the opinion of the greatest of medieval scientists with regard to the reason why men do not obtain real knowledge more rapidly than would seem ought to be the case, from the amount of work which they have devoted to obtaining it. Roger Bacon, summing up for Pope Clement the body of doctrine that he was teaching at the University of Oxford in the 13th century, starts out with the principle that there are four grounds of human ignorance. Quote, "These are first, trust in inadequate authority. Second, the force of custom, which leads men to accept too unquestioningly what has been accepted before their time. Third, the placing of confidence in the opinion of the inexperienced. And fourth, the hiding of one's ignorance with the parade of superficial wisdom." Close quote. Surely no one will ever be able to improve on these four grounds for human ignorance, and they continue to be as important in the 20th century as they were in the 13th. They could only have emanated from an eminently practical mind, accustomed to test by observation and by careful searching of authorities every proposition that came to him. Professor Henry Morley, professor of English literature at University College London, says of these grounds for ignorance of Roger Bacon in his English Writers, Volume 3, page 321, quote, "No part of the ground has yet been cut away from beneath the feet of students, although 6 centuries ago the Oxford friar clearly pointed out its character. We still make sheep walks of second, third, and fourth, and 15th hand references to authority. Still we are the slaves of habit. Still we are found following too frequently the untaught crowd. Still we flinch from the righteous and wholesome phrase, 'I do not know,' and acquiesce actively in the opinion of others that we know what we appear to know. Substitute honest research, original and independent thought, strict truth in the comparison of only what we really know with what is really known by others, and the strong redoubt of ignorance has fallen." End of quote. The number of things which Roger Bacon succeeded in discovering by the application of the principle of testing everything by personal observation is almost incredible to a modern student of science and of education who has known nothing before of the progress in science made by this wonderful man. He has been sometimes declared to be the discoverer of gunpowder, but this is a mistake, since it was known many years before by the Arabs and by them introduced into Europe. He did study explosives very deeply, however, and besides learning many things about them, realized how much might be accomplished by their use in the aftertime. He declares in his Opus Magnum, quote, "that one may cause to burst forth from bronze thunderbolts more formidable than those produced by nature. A small quantity of prepared matter occasions a terrible explosion accompanied by a brilliant light. One may multiply this phenomenon so far as to destroy a city or an army." Closed quote. Considering how little was known about gunpowder at this time, this was of itself a marvelous anticipation of what might be accomplished by it. Bacon prophesied, however, much more than merely destructive effects from the use of high explosives, and indeed it is almost amusing to see how closely he anticipated some of the most modern usages of high explosives for motor purposes. He seems to have concluded that sometime the apparently uncontrollable force of explosion would come under the control of man and be harnessed by him for his own purposes. He realized that one of the great applications of such a force would be for transportation. Accordingly, he said, quote, "Art can construct instruments of navigation such that the largest vessels governed by a single man will traverse rivers and seas more rapidly than if they were filled with oarsmen. One may also make carriages which, without the aid of any animal, will run with remarkable swiftness." Close quote. When we recall that the very latest thing in transportation are motorboats and automobiles driven by gasoline, a high explosive, Roger Bacon's prophecy became one of these weird anticipations of human progress which seem almost more than human. It was not with regard to explosives alone, however, that Roger Bacon was to make great advances and still more marvelous anticipations in physical science. He was not, as is sometimes claimed for him, either the inventor of the telescope or of the theory of lenses. He did more, however, than perhaps anyone else to make the principles of lenses clear and to establish them on a mathematical basis. His traditional connection with the telescope can probably be traced to the fact that he was very much interested in astronomy and the relations of the heavens to the earth. He pointed out very clearly the errors which had crept into the Julian calendar, calculated exactly how much of a correction was needed in order to restore the year to its proper place, and suggested the method by which future errors of this kind could be avoided. His ideas were too far beyond his century to be applied in a practical way, but they were not to be without their effect, and it is said that they formed the basis of the subsequent correction of the calendar in the time of Pope Gregory XIII 3 centuries later. It is rather surprising to find how much besides the theory of lenses Friar Bacon had succeeded in finding out in the department of optics. He taught, for instance, the principle of the aberration of light, and, still more marvelous to consider, taught that light did not travel instantaneously, but had a definite rate of motion, though this was extremely rapid. It is rather difficult to understand how he reached this conclusion, since light travels so fast that as far as regards any observation that can be made upon earth, the diffusion is practically instantaneous. It was not for over 3 centuries later that Romer, the German astronomer, demonstrated the motion of light and its rate by his observations upon the moons of Jupiter at different phases of the earth's orbit, which showed that the light of these moons took a definite and quite appreciable time to reach the earth after their eclipse by the planet was over. We are not surprised to find that Bacon should praise those of his contemporaries who devoted themselves to mathematics and to experimental observations in science. Of one of his correspondents who even from distant Italy sent him observations in order that he might have the great Franciscan's precious comments on them, Bacon has given quite a panegyric. The reasons for his praise, however, are so different from those which are ordinarily proclaimed to have been the sources of laudation in distant medieval scientific circles, that we prefer to quote Bacon's own words from the Opus Tertium. Bacon is talking of Petrus Peregrinus and says, quote, "I know of only one person who deserves praise for his work in experimental philosophy, for he does not care for the discourses of men and their wordy warfare, but quietly and diligently pursues the works of wisdom. Therefore, what others grope for blindly as bats in the evening twilight, this man contemplates in all their brilliancy, because he is a master of experiment. Hence he knows all natural science, whether pertaining to medicine and alchemy, or to matters celestial and terrestrial. He has worked diligently in the smelting of ores, as also in the working of minerals. He is thoroughly acquainted with all sorts of arms and implements used in military service and in hunting, besides which he is skilled in agriculture and in the measurement of lands. It is impossible to write a useful or correct treatise in experimental philosophy without mentioning this man's name. Moreover, he pursues knowledge for its own sake, for if he wished to obtain royal favor, he could easily find sovereigns who would honor and enrich him." Close quote. Lest it should be thought that these expressions of laudatory appreciation of the great 13th century scientist are dictated more by the desire to magnify his work and to bring out the influence in science of the churchmen of the period, it seems well to quote an expression of opinion from the modern historian of the inductive sciences, whose praise is scarcely, if any, less outspoken than that of others whom we have quoted, and who might be supposed to be somewhat partial in their judgment. This opinion will fortify the doubters who must have authority, and at the same time sums up very excellently the position which Roger Bacon occupies in the history of science. Dr. Whewell says that Roger Bacon's Opus Majus is, quote, the encyclopedia and novum organon of the 13th century, a work equally wonderful with regard to its general scheme and to the special treatises with which the outlines of the plans are filled up. The professed object of the work is to urge the necessity of a reform in the mode of philosophizing, to set forth the reasons why knowledge has not made a greater progress, to draw back attention to the sources of knowledge which had been unwisely neglected, to discover other sources which were yet almost untouched, and to animate men in the undertaking by a prospect of the vast advantages which it offered. In the development of this plan, all the leading portions of science are expanded in the most complete shape which they had at that moment assumed, and improvements of a very wide and striking kind are proposed in some of the principal branches of study. Even if the work had no leading purposes, it would have been highly valuable as a treasure of the most solid knowledge and soundest speculations of the time. Even if it had contained no such details, it would have been a work most remarkable for its general views and scope. Close quote. It is only what might have been expected, however, from Roger Bacon's training that he should have made great progress in the physical sciences. At the University of Paris, his favorite teacher was Albertus Magnus, who was himself deeply interested in all the physical sciences, though he was more concerned with the study of chemical problems than of the practical questions which were to occupy his greatest pupil. There is no doubt at all that Albertus Magnus accomplished a great deal of experimental work in chemistry, and had made a large series of actual observations. He was a theologian as well as a philosopher and a scientist. Some idea of the immense industry of the man can be obtained from the fact that his complete works as published consist of some 20 large folio volumes, each one of which contains on the average at least 500,000 words. Among these works are many treatises relating to chemistry. The titles of some of them will serve to show how explicit was Albert in his consideration of various chemical subjects. He has treatises concerning metals and minerals, concerning alchemy, a treatise on the secret of chemistry, a concordance, that is, a collection of observations from many sources with regard to the philosopher's stone, a brief compend on the origin of the metals, a treatise on compounds. Most of these are to be found in his works under the general heading Theatrum Chemicum. It is not surprising for those who know of Albert's work to find that his pupil, Roger Bacon, defined the limits of chemistry very accurately, and showed that he understood exactly what the subject and the methods of investigation must be, in order that advance should be made in it. Of chemistry he speaks in his Opus Tertium in the following words, quote, "There is a science which treats of the generation of things from their elements, and of all inanimate things, as of the elements and liquids, simple and compound, common stones, gems and marble, gold and other metals, sulfur, salts, pigments, lapis lazuli, minium and other colors, oils, bitumen, and infinite more, of which we find nothing in the books of Aristotle. Nor are the natural philosophers, nor any of the Latins acquainted with these things." Close quote. In physics, Albertus Magnus was, if possible, more advanced and progressive even than in chemistry. His knowledge in the physical sciences was not merely speculative, but partook to a great degree of the nature of what we now call applied science. Humboldt, the distinguished German natural philosopher of the beginning of the 19th century, who was undoubtedly the most important leader in scientific thought in his time, and whose work was great enough to have an enduring influence in spite of the immense progress of the 19th century, has summed up Albert's work and given the headings under which his scientific research must be considered. He says, quote, Albertus Magnus was equally active and influential in promoting the study of natural science and of the Aristotelian philosophy. His works contain some exceedingly acute remarks on the organic structure and the physiology of plants. One of his works, bearing the title of Liber Cosmographicus de Natura Locorum, is a species of physical geography. I have found in it considerations on the dependence of temperature concurrently on latitude and elevation, and on the effect of different angles of incidence of the sun's rays in heating the ground, which have excited my surprise. Close quote. To take up some of Humboldt's headings in their order, and illustrate them by quotations from Albert himself, and from condensed accounts as they appear in his biographer Sighart and in Christian Schools and Scholars, will serve to show at once the extent of Albert's knowledge and the presumptuous ignorance of those who make little of the science of the medieval period. When we have catalogued, for instance, the many facts with regard to astronomy and the physics of light that are supposed to have come by human ken much later, yet may be seen to have been clearly within the range of Albert's knowledge, and evidently formed the subject of his teaching at various times at both Paris and Cologne, for they are found in his authentic works, we can scarcely help but be amused at the pretentious misconception that has relegated their author to a place in education so trivial as is that which is represented in many minds by the term scholastic. Footnote from Christian Schools and Scholars by Drain. Quote, He decides that the Milky Way is nothing but a vast assemblage of stars, but supposes, naturally enough, that they occupy the orbit which receives the light of the sun. The figures visible on the moon's disk are not, he says, as hitherto has been supposed, reflections of the seas and mountains of the earth, but configurations of her own surface. He notices, in order to correct it, the assertion of Aristotle that lunar rainbows appear only twice in 50 years. Quote, I myself, he says, have observed 2 in a single year. Close quote. He has something to say on the refraction of a solar ray, notices certain crystals which have a power of refraction, and remarks that none of the ancients and few moderns were acquainted with the properties of mirrors. End of footnote. Albert's great pupil, Roger Bacon, is rightly looked upon as the true father of inductive science, an honor that history has unfortunately taken from him to confer it undeservedly on his namesake of 4 centuries later. But the teaching out of which Roger Bacon was to develop the principles of experimental science can be found in many places in his master's writings. In Albert's 10th book, wherein he catalogues and describes all the trees, plants, and herbs known in his time, he observes, quote, All that is here set down is the result of our own experience, or has been borrowed from authors whom we know to have written what their personal experience has confirmed. For in these matters, experience alone can give certainty. Close quote. Experimentum solum certificat in tabulis. Quote, Such an expression, close quote, says his biographer, quote, which might have proceeded from the pen of Francis Bacon, argues in itself a prodigious scientific progress, and shows that the medieval friar was on the track so successfully pursued by modern natural philosophy. He has fairly shaken off the shackles which had hitherto tied up discovery, and was the slave neither of Pliny nor of Aristotle. Close quote. Botany is supposed to be a very modern science, And to most people, Humboldt's expression that he found in Albert Magnus's writings some, quote, exceedingly acute remarks on the organic structure and the physiology of plants, close quote, will come as a supreme surprise. A few details with regard to Albert's botanical knowledge, however, will serve to heighten that surprise, and to show that the foolish tirades of modern sciolists, who have often expressed their wonder that with all the beauties of nature around them, the scholars of the Middle Ages did not devote themselves to nature study, are absurd, because if the critics but knew it, there was a profound interest in nature and all her manifestations, and a series of discoveries that anticipated not a little of what we consider most important in our modern science. The story of Albert's botanical knowledge has been told in a single, very full paragraph by his biographer. Sighart also quotes an appreciative opinion from a modern German botanist, which will serve to dispel any doubts with regard to Albert's position in botany that modern students might perhaps continue to harbor, unless they had good authority to support their opinion, though of course it will be remembered that the main difference between the medieval and the modern mind is only too often said to be that the medieval required an authority, while the modern makes its opinion for itself. Even the most skeptical of modern minds, however, will probably be satisfied by the following paragraph. Quote, he was acquainted with the sleep of plants, with the periodical opening and closing of blossoms, with the diminution of sap through evaporation from the cuticle of the leaves, and with the influence of the distribution of the bundles of vessels on the folial indentations. His minute observations on the forms and variety of plants imitate an exquisite sense of floral beauty. He distinguished the star from the bell floral, tells us that a red rose will turn white when submitted to the vapors of sulfur, and makes some very sagacious observations on the subject of germination. The extraordinary erudition and originality of this treatise, his 10th book, has drawn from M. Meyer the following comment, quote, no botanist who lived before Albert can be compared to him, unless Theophrastus, with whom he was not acquainted, and after him none has painted nature in such living colors, or studied it so profoundly, until the time of Conrad Gessner and Cesalpino. All honor, then, to the man who made such astonishing progress in the science of nature as to find no one, I will not say to surpass, but even to equal him for the space of 3 centuries. Close quote. We point out in the chapter on Geography and Exploration how much this wonderful 13th century added to the knowledge of geographical science. Even before the great explorers of this time, however, had accomplished their work, this particular branch of science had made such great progress as would bring it quite within the domain of what we call the science of geography at the present time. When we remember how much has been said about the ignorance of the men of the later Middle Ages as regards the shape of the earth and its inhabitants, and how many foolish notions they are supposed to have accepted with regard to the limitation of possible residence of the world, and the queer ideas as to the antipodes, the following passage, taken from Albert's biographer, will serve better than anything else to show how absurdly the traditional notions with regard to this time and its knowledge have been permitted by educators to tinge what are supposed to be serious opinions with regard to the subject matters of education in that early university period. Quote, he treats as fabulous the commonly received idea in which Bede has acquiesced, that the region of the earth south of the equator was uninhabitable, and considers that from the equator to the South Pole the earth was not only habitable, but in all probability actually inhabited, except directly at the poles, where he imagines the cold to be excessive. If there are any animals there, he says, they must have very thick skins to defend them from the rigor of the climate, and they are probably of a white color. The intensity of cold is, however, tempered by the action of the sea. He describes the antipodes and the countries they comprise, and divides the climate of the earth into 7 zones. He smiles with a scholar's freedom at the simplicity of those who suppose that persons living at the opposite region of the earth must fall off, an opinion that can only rise out of the grossest ignorance. Quote, "For when we speak of the lower hemisphere, this must be understood merely as relatively to ours." Close quote. It is as a geographer that Albert's superiority to the writers of his own time chiefly appears. Bearing in mind the astonishing ignorance which then prevailed on this subject, it is truly admirable to find him correctly tracing the chief mountain chains of Europe, with the rivers which take their source in each. Remarking on portions of coast which have in latter times been submerged by the ocean, and islands which have been raised by volcanic action above the level of the sea, noticing the modification of climate caused by mountains, seas, and forests, and the division of the human race whose differences he ascribes to the effect upon them of the countries they inhabit. In speaking of the British Isles, he alludes to the commonly received idea that another distant island called Tile or Thule existed far in the Western Ocean, uninhabitable by reason of its frightful climate, but which, he says, has probably not yet been visited by man. Close quote. Nothing will so seriously disturb the complacency of modern minds as to the wonderful advances that have been made in the last century in all branches of physical science, as to read Albertus Magnus's writings. Nothing can be more wholesomely chastening of present-day conceit than to get a proper appreciation of the extent of the knowledge of the schoolmen. Albertus Magnus's other great pupil, besides Roger Bacon, was St. Thomas Aquinas. If any suspicion were still left that Thomas did not appreciate just what the significance of his teachings in physics was when he announced that neither matter nor force could ever be reduced to nothingness, it would surely be removed by the consideration that he had been for many years in intimate relations with Albert, and that he had probably also been close to Roger Bacon. After association with such men as these, any knowledge he displays with regard to physical science can scarcely be presumed to have been stumbled upon unawares. St. Thomas himself has left 3 treatises on chemical subjects, and it is said that the first occurrence of the word amalgam can be traced to one of these treatises. Everybody was as much interested then as we are at the present time in the transformation of metals, and mercury, with its silvery sheen, its facility to enter into metallic combinations of all kinds, and its elusive ways, naturally made it the center of scientific interest, quite as radium is at the present moment. Further material with regard to St. Thomas, and also to the subject of education, will be found in the chapter Aquinas the Scholar. After this brief review of only a few of the things that they taught in science at the 13th century universities, most people will scarcely fail to wonder how such peculiar erroneous impressions with regard to the uselessness of university teaching and training have come to be so generally accepted. The fault lies, of course, with those who thought they knew something about university teaching, and who, because they found a few things that now look ridiculous, as certain supposed facts of one generation always will to succeeding generations who know more about them, thought they could conclude from these as to the character of the whole content of medieval education. It is only another example of what Artemus Ward pointed out so effectively when he said that, quote, "There is nothing that makes men so ridiculous as the knowing so many things that ain't so." Close quote. We have been accepting without question ever so many things that simply are not so with regard to these wonderful generations, who not only organized the universities, but organized the teaching in them on lines not very different from those which occupy people 7 centuries later. What would be the most amusing feature, if it were not unfortunately so serious an arrangement of the literature that has grown up around these peculiar baseless notions with regard to scholastic philosophy, is the number of men of science who have permitted themselves to make fun of certain supposed lucubrations of the great medieval philosophers. It is not so very long ago that, as pointed out by Harper in the Metaphysics of the School, Professor Tate, in a lecture on some recent advances in physical science, repeated the old slander that even Aquinas occupied the attention of his students with such inane questions as how many angels could dance on the point of a needle. Modern science very proudly insists that it occupies itself with observations and concerns itself little with authority. Professor Tate, in this unhappy quotation, shows not only that he has made no personal studies in medieval philosophy, but that he has accepted a very inadequate authority for the statements which he makes with as much confidence as if they had been the result of prolonged research in the field. Many other modern scientists have fallen into like blunders. The modern student, as well as the teacher, is prone to wonder what were the methods of study and the habits of life of the students of the 13th century, and fortunately we have a short sketch written by Robert of Sorbonne, the famous founder of the Sorbonne, in which he gives advice to attendants at that institution as to how they should spend their time, so that at least we are able to get a hint of the ideals that were set before the student. Robert, whose long experience of university life made him thoroughly competent to advise, said, quote, "The student who wishes to make progress ought to observe 6 essential rules. First, he ought to consecrate a certain hour every day to the study of a determined subject, as St. Bernard counseled his monks in his letter to the brothers of the Mont Dieu. Second, he ought to concentrate his attention upon what he reads, and ought not to let it pass lightly. There is between reading and study, as St. Bernard says, the same difference as between a host and a guest, between a passing salutation exchanged in the street and an embrace prompted by an unalterable affection. Third, he ought to extract from the daily study one thought, some truth or other, and engrave it deeply upon his memory with special care. Seneca said, cum multa percorreris in die, unum tibi eligit quod illa die excoquas. When you have run over many things in a day, select one for yourself which you should digest well on that day. Fourth, write a resume of it, for words which are not confined to writing fly as does the dust before the wind. Fifth, talk the matter over with your fellow students, either in the regular recitation or in your familiar conversation. This exercise is even more profitable than study, for it has the result of clarifying of all doubts and the removing of all the obscurity that study may have left. Nothing is perfectly known unless it has been tried by the tooth of disputation. Sixth, pray, for this is indeed one of the best ways of learning. St. Bernard teaches that study ought to touch the heart, and that one should profit by it always by elevating the heart to God, without, however, interrupting the study." Close quote. Sorbonne proceeds in a tone that vividly recalls the modern university professor who has seen generation after generation of students and has learned to realize how many of them waste their time. Quote, "Certain students act like fools. They display great subtlety over nonsensical subjects, and exhibit themselves devoid of intelligence with regard to their most important studies. So as not to seem to have lost their time, they gather together many sheets of parchment, make thick volumes of notebooks out of them, with many a blank interval, and cover them with elegant binding and red letters. Then they return to their paternal domicile with their little sack filled up with knowledge which can be stolen from them by any thief that comes along, or may be eaten by rats or by worms, or destroyed by fire or water. In order to acquire instruction, the student must abstain from pleasure, and not allow himself to be hampered by material cares. There was at Paris, not long since, 2 teachers who were great friends. One of them had seen much, had read much, and used to remain night and day bent over his books. He scarcely took the time to say an Our Father. Nevertheless, he had but 4 students. His colleague possessed a much less complete library, was less devoted to study, and heard Mass every morning before delivering his lecture. In spite of this, his classroom was full. "How do you do it?" asked his friend. "It is very simple," said his friend, smiling. "God studies for me. I go to Mass, and when I come back, I know by heart all that I have to teach." Close quote. Meditation, so Sorbonne continues, is suitable not only for the master, but the good student ought also to go and take his promenade along the banks of the Seine, not to play there, but in order to repeat his lesson and meditate upon it. Close quote. These instructions for students are not very different from those that would be issued by an interested head of university department to the freshmen of the present day. His insistence especially on the difference between reading and study might very well be taken to heart at the present time, when there seems to be some idea that reading of itself is sufficient to enable one to obtain an education. The lesson of learning one thing a day, and learning that well, might have been selected as a motto for students for all succeeding generations, with manifest advantage to the success of college study. In other things, Sorbonne departs further from our modern ideas in the matter of education, but still there are many even at the present time who will read with profound sympathy his emphatic advice to the university students that they must educate their hearts as well as their intellects, and make their education subserve the purpose of bringing them closer to God. A word about certain customs that prevailed more or less generally in the universities at this time, and that after having been much misunderstood will now be looked at more sympathetically in the light of recent educational developments, will not be out of place here. One of the advantages of modern German university education has often been acclaimed to be the fact that students are tempted to make portions of their studies in various cities, since all the courses are equalized in certain ways, so that the time spent at any one of them will be counted properly for their degrees. It has long been recognized that travel makes the best possible complement to a university course, and even when the English universities in the 18th century sank to be little more than pleasant abiding places where young men of the upper classes ate their terms, the fact that it was the custom to make the grand tour of continental travel supplied for much that was lacking in the serious side of their education. Little as this might be anticipated as a feature of the ruder times of the 13th century, when travel was so difficult, it must be counted as one of the great advantages for the inquiring spirits of the time. Dante, besides attending the universities in Italy, and he certainly was at several of them, was also at Paris at one time, and probably also at Oxford. Professor Monroe, in his textbook in the History of Education, has stated this custom very distinctly. Quote, "With the founding of the universities, and the establishment of the nations in practically every university, it became quite customary for students to travel from university to university, finding in each a home in their appropriate nation. Many, however, willing to accept the privileges of the clergy and the students without undertaking their obligations, adopted this wandering life as a permanent one. Being a privileged order, they readily found a living or made it by begging. A monk of the early university period writes, quote, "The scholars are accustomed to wander throughout the whole world and visit all the cities, and their studies bring them understanding. For in Paris they seek a knowledge of the liberal arts, of the ancient writers at Orleans, of medicine at Salernum, of the black art at Toledo, and in no place decent manners." Close quote. With regard to the old monk's criticism, it must be remembered that old age is always rather depreciative in criticism of the present and over-appreciative of what happened in the past saepueris. Abuses always seem to be creeping in that are going to ruin the force of education, yet somehow the next generation succeeds in obtaining its intellectual development in rather good shape. Besides, as we must always remember in educational questions, evils are ever exaggerated, and the memory of them is prone to live longer and to loom larger than that of the good with which they were associated, and to which, indeed, as anyone of reasonable experience in educational circles knows, they may constitute by comparison only a very small amount. Undoubtedly, the wanderings of students brought with it many abuses, and if we were to listen to some of the stories of foreign student life in Paris in our own time, we might think that much of evil and nothing of good was accomplished by such wandering, but insomuch as we do, we invite serious error of judgment. Another striking feature of university life, which constituted a distinct anticipation of something very modern in our educational system, was the lending of professors of different nationalities among the universities. It is only at the beginning of the 20th century that we have re-established this custom. In the 13th century, however, Albertus Magnus taught for a time at Cologne, and then later at Paris, and apparently also at Rome. St. Thomas of Aquin, after having taught for a time at Paris, lectured in various Italian universities, and then finally at the University of Rome, to which he was tempted by the popes. Duns Scotus, besides teaching at Oxford, taught also at Paris. Alexander of Hales before him seemed to have done the same thing. Roger Bacon, after studying at the University of Paris, seems to have commenced teaching there, though most of his professional work was accomplished at the University of Oxford. Raymond Lully probably had professional experiences at several Spanish universities besides at Paris. In a word, if a man were a distinguished genius, he was almost sure to be given the opportunity to influence his generation at a number of centers of educational life, and not be confined, as has been the case in the centuries since, to but one, or at most, and that more by accident than intent, to perhaps two. In a word, there is not a distinctive feature of modern university life that was not anticipated in the 13th century.